All right, hello. We are going to finish 9.1. We've got one content idea and then two examples. So the first thing to note is that as we are doing any of these significance tests, we obviously hope we are correct, that whatever conclusion we make is right. But there's also a possibility for something to go wrong. And let's talk about those mistakes because they're very important. So there's two options for what could be true about the population. Either the null hypothesis is actually true or the null hypothesis is false, right? Those are the only options. Either Mr. Alinsky actually is a 80% free throw shooter or he is not. And the conclusions we can make would be to either reject the null hypothesis or fail to reject the null hypothesis. Based on the colors I have, it might be, maybe obvious is the wrong word, but it might be clear that in the cases where we've got red, this is going to be a mistake. So if the null hypothesis is true and we reject the null, we say we don't think it's true, we have made a mistake. This is known as a type 1 error. If the null hypothesis is false and we reject it, then we've made the right choice and we are happy. If the null hypothesis is true and we fail to reject it, we don't reject it, then we've, again, made the right decision. But if the null is false and we fail to reject it, we have made what is known as a type 2 error. They're really creative with their naming of errors. One thing that might help is a type 2 error is when you fail to reject the null hypothesis, but the null is false. And so we are going to be asked a lot of the time to consider what would a type 1 error look like? What would a type 2 error look like? And when we're doing a significance test, we want to avoid the worse error. If we think about this in the context of our criminal trial, and this will just maybe kind of help us get a little bit of a grip on kind of what's going on. Oh gosh, that was terrible. Either, that was not much better, but whatever, it's gonna have to do. Either the person is innocent or they're guilty, and we're either going to convict them or we will not convict them. And of course, if they are guilty and we convict them, then we're happy because we made the right choice. If we're innocent and we do not convict them, again, we're happy because we made the right choice, but then we've got these mistakes. And the question, and this would be a really good debate, is which of these is worse? Is it worse to convict an innocent man or to let someone guilty go free? And I think there's a lot to be said about either of those ideas, and I don't know that right now is the right time to have that discussion because obviously there's a lot of factors involved, but that's the question we have here, that sometimes it's worse to have an innocent man convicted, especially if it's a crime that obviously they did not commit, but a super big crime. But sometimes, let's say if me as a teacher didn't give you a demerit, I did give you a demerit, but then Mrs. Brock yells at me. I've been convicted of not giving you a demerit even though I did. Like, that's not a bad mistake to make. And then if on the flip side, if we let someone guilty go free, that could be really bad. We don't want a murderer on the streets, but it also might not be the worst thing in the world, right? So it all depends on the context about whether a type 1 or a type 2 error is worse. So let's look at an example to kind of see where these two things come into play. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait more than 2 minutes to receive their food once their order is placed. Based on store records, the proportion of customers who have to wait at least 2 minutes was 0.63. 63% of people have to wait at least 2 minutes. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. During the next month, the manager will collect a random sample of drive-through times and test the following hypotheses: that the true proportion is 63, or that the true proportion has gone down. He is hoping that by adding an additional person, the amount of wait time at that drive-through will go down. Where P is the true proportion of drive-through customers who will have to wait more than 2 minutes after the order is placed to receive their food. They want us to describe a type 1 and a type 2 error in this setting. So to help us, I'm going to redraw my table, but I'm going to give context to the problem. So either the null is true, P is equal to 0.63, or the null is not true, which would mean the alternate is true. And either we are going to reject it, or we will fail to reject it. I know that if the null is true and we reject it, we have made a type 1 error. And I know if the null is false and we fail to reject it, we have made a type 2 error. Again, these are okay spots to be. So let's describe what each of these would be. And let's talk about a potential consequence of each of these errors. A type 1 error is that the null hypothesis is true, but we reject it. So the manager believes that the time has gone down. They reject the null, meaning we have evidence of the alternate. The manager believes the time has gone down, but no actual change has been made. He believes the time has gone down. He thinks the alternate is true, but the null is still true. This is a type 1 error. What would be the problems of this error? Well, if he thinks that the time has gone down, but it actually hasn't been getting better, then he's paying an employee that is not helping. He's paying an employee who isn't actually helping. This is one consequence, right? It's maybe not the only one. So what then would a type 2 error look like? For a type 2 error, we fail to reject the null when the null is false. So in this case, the manager believes the proportion has stayed the same. Manager believes proportion has stayed the same. Why does he believe that? Because he failed to reject it, even though there has been improvement. I know there has been improvement because P is actually less than 0.63. So what would be a consequence of this? Well, he could think, hey, that extra employee did not actually help. He could theoretically fire an employee who is helping. And maybe fire is a bit too far, right? Maybe not fire, but that he just doesn't assign this kid to the shifts. But that person is actually helping. There has been an improvement, but the manager doesn't think so. So he's not going to waste his money paying this guy to go help the drive-through. And the question I think then becomes, which of these is worse? Is it worse to pay an employee who isn't actually helping, to think that you're doing good by your customers, but you're actually not? Or to fire someone who is doing good? So to kind of take a step back, that you're actually helping your customers, but you don't realize you are. And honestly, I don't know what the answer is. There might not be a best solution. They would never ask you which is the best unless they gave you a criteria. So if we didn't want to waste more money, then probably this type 1 error would be the worst mistake. Let's look at one more thing. In our fast food example, we are testing the following hypotheses: that the proportion of people who wait more than 2 minutes is 0.63 was our null hypothesis, and the alternate was that that has gone down. P is less than 0.63. Suppose that the manager decides to carry out this test using a random sample of 250 orders, and he has a significance level of 0.10. What is the probability of making a type 1 error? Oh, this is an interesting question. Let's consider it. The probability that I make a type 1 error. Well, first let's remind ourselves, what does it mean to make a type 1 error? Making a type 1 error means I reject the null, but the null hypothesis is true. Okay, let's think about this. When do we reject our null hypothesis? We reject our null hypothesis when our p-value is less than our significance level. And in this case, we know our significance level. We are going to reject the null when the p-value is less than 0.10. Okay, now let's consider the second piece. Our null hypothesis is true. So let's look at this distribution. If the null hypothesis is true, I know the mean of all of my p-hats is equal to p, and because our null hypothesis is true, I know it's 0.63. In this distribution are all my possible statistics. All of my possible statistics. And I know that I am going to reject the null hypothesis when my p-value is less than 0.1. I should have done this before, I'm sorry. Let's go back to this statement. Okay, p-value. What is a p-value again? It's the probability that we would get a statistic this small or smaller. I'm saying small because in this problem, we are looking at less than 0.63. And so if I'm considering a statistic that is small or smaller than 0.10, let's look at our distribution. Let's pretend that this area right here is 0.10. It's less than, I know it's got to be less than 50, right? And maybe I drew it a little too far over, but we're going to pretend that that is an area of 0.10. If I have this statistic, the likelihood that this statistic would happen, or more extreme, would be about 50%, right? This statistic or less than it. So that's not what we're looking at. But if I move this statistic over here, then the likelihood of this little guy happening, or more extreme, is going to be less than 10%. So how much of the time are we going to reject the null when the null is true? Well, it's this area right here. Any statistic that falls within this area will give us a p-value that is less than our significance level that will make us reject the null even though the null is true. So the probability of a type 1 error is 0.10. In this example, it's our significance level. And maybe that was a little confusing to you, and that's fair if it was. And so what I want to say is, and this is maybe not the best thing, but like just write the really important thing that we just figured out down. The probability of a type 1 error is our significance level. It will always be. And so that's why we might change our significance level. If I don't want to make a type 1 error, then I will make my significance level smaller. I will reduce the chances of that happening. If I think a type 2 error is worse, then a higher significance level isn't as bad. So the probability of a type 1 error is equal to our significance level. Thank you for watching. We will be continuing with 9.2 on Friday. Let me know if you have questions, start on the 6.1 homework, and have a great rest of your day.